Hello everybody, welcome back, and in this video we are going to learn about porosity, permeability, as well as aquifer and aquitort later on. Alright, let me start with this. If you take a look and if you try to search illustration for groundwater, there's always this misconception that I often find out there. For example, it often illustrates that there's a river flowing underground, as you can see here in this picture on the right side, as well as this picture right here on the left side, right? So both pictures shows that we have rivers that flow underground, and in most cases, I have to say that this is not true. All right, of course, in some cases, yes, this could be true, especially if you're dealing with limestone bedrock that can easily be dissolved in water and eventually can create rivers underground. But in most cases, this is not true, that we do not have rivers underground. Because water underground is often stored within what we call as pore spaces. Okay, pore spaces. So what are pore spaces? Again, pore spaces are just empty spaces that are located in between the grains of sediments. Okay, so for example, this could be a sandstone, and here I have one sand grain, two sand grain, three sand grain, four sand grains right here. We have four sand grains, and in between those four sand grains, we have the empty space in between, and this is what we call as a pore space. Okay, pore spaces. And rocks have this important property which is called porosity, and what porosity is that it is the total volume of all pore spaces that is measured as a percentage of total rock volume. Okay. All right, and there can be considerable range in porosity between different types of rocks or the same type of rocks. For example, here let me highlight one of the best example for rocks that have high porosity, right? 30% for alien sandstone. So sandstone is a type of rock that is very well known to have high porosity, okay, which means it has lots of pore spaces within the rocks, okay. And we could also have some other types of rocks, for example, like limestone, especially weathered limestone, or vesicular basalt right here. All right, and some other rocks, for example, crystalline rocks such as igneous rocks or metamorphic rocks. These are rocks that commonly have a very low porosity, and in this example, look at this, it actually gives less than 1% of porosity, which means it's almost nothing, right? There's almost virtually no porosity at all within the rocks. The second rock property that I would like to introduce you with is called permeability. So what is permeability? It is actually the ability for the rocks to transmit fluids, and in this case, of course, we're talking about groundwater. Okay, so for example, just to give you a better illustration of this, I have two rocks, rock A at the top and rock B at the bottom here. Rock A has pore spaces illustrated by these blue areas right here. Okay, so we see some pore spaces within rock A, and rock B obviously has a lot more pore spaces, but one of the most important thing that we need to highlight here is that the pore spaces within rock A, they are just not well connected, okay? For example, we have isolated pore spaces right there, another one isolated right there, another one isolated right there. So these pore spaces are not in communication with each other. So therefore, it can be considered as, rock A has a very low permeability, okay? Whereas rock B here, we see lots of blue areas, but again, the most important thing here is that those blue areas are well connected, okay? And these well connected pore spaces will allow this rock to be able to transmit fluids easily, say from point A here on the left to point B here on the right side. So therefore, the permeability for rock B is much higher than rock A. Okay, so those are the two main properties, rock properties, that I want you to know. porosity and permeability. Okay. Now, what are the type of rocks that have relatively high porosity and high permeability? And that rock is called aquifer. Okay, so aquifer is sedimentary rocks or rocks that water can flow easily. Okay, these rocks are typically known to be a very good rock that is able to hold lots of water as well as to allow the water to flow easily through it. Okay, and the example for that would be sand and gravel, okay, weathered limestone, or we could also have some crystalline rocks, but it must be fractured. Okay, these crystalline rocks must be fractured again to allow some openings within the rocks and allow the the water to go through easily through it. Okay. And here is an example of weathered joints and bedding plane fractures that can transmit large amounts of water. So this is what it looks like in nature right here. So even though if we're having like crystalline rocks with commonly have a very low porosity and permeability, as long as we have this fractures within rocks, and these are basically also open spaces within the rocks that the water can occupy. All right, again, aquifer is sediments, rock through which water flows easily, and there are two types of aquifer that we know. The first one is called unconfined aquifer, and the second one is called confined aquifer. Okay, unconfined aquifer is this one right here at the top of this picture right here. That the top of that aquifer intersects with the surface or the ground surface. Okay, so there's nothing holding right above that aquifer, and that'll be called unconfined aquifer. Now that is completely different with confined aquifer. Of course, confined aquifer typically is kept by what we call as impermeable layer right here. Okay, so we have an aquifer here, and at the top of it there's impermeable layer that sits on top of that aquifer, and that'll be called unconfined aquifer. Okay, what is this? It's bracketed by aquitard. So what is aquitard? Aquitard are rocks that block water, that blocks water flow entirely. Okay, and in this example it is illustrated by this impermeable layer that sits right here in between the two aquifers. Okay, so here's another example of aquifer and confining beds or aquitards. Okay, so aquifers are illustrated by this yellow area right here. As you can see here, it got filled with water, and here we have unconfined aquifer sitting at the top here. Again, the top of this aquifer intersects with the ground surface. Whereas this one here is called confined aquifer because the top of the aquifer is bounded by an impermeable layer or an aquitard. Okay. Now one might ask, okay, if we have confined aquifer that has impermeable layer at the top of it, how do we get water into that confined aquifer? And the answer for that is the recharge area for that aquifer is actually way upstream of that aquifer. Typically it happens, the recharge process happens in higher elevations, allowing the water to seep into the ground, all right, and flows downward and fill the confined aquifer in this region. Okay. All right, so those are aquifer, aquitards, porosity, and permeability, the stuff that I would like you to know for this in this video. Okay, and I'll see you again in the next one. Bye bye.